I'm convinced that our universe is haunted by ghosts. Not the kind that go bump in the night, but the kind that go crunch in the Big Bang. And not ghosts, really, more like gremlins. Gremlins who, if given half a chance, will undo the Big Bang and start the whole thing over again. And what makes me so sure about this? Well, it's because of all the time travel that goes on in our universe. Time travel that would be fine if our universe were made of green jelly, but it's not. It's made of something far more fragile, space-time. See, there are mathematical solutions to Einstein's equations that describe tunnels through space-time called wormholes. We know that because the maths works out in principle. But we don't know whether they actually exist because we've never seen one. And we have no reason to believe that they do exist, even though physicists often talk about them. You may have heard Stephen Hawking's famous suggestion that if you found yourself at one end of a wormhole, you should stick your hand in and pull the other end towards you so that you could then travel through the wormhole and meet yourself and shake hands with yourself or something. That idea requires the wormhole to exist in the first place, which we have no reason to assume. But assuming they do exist, what's so bad about them? Well, for one thing, they're unstable as hell. Any little nudge can cause them to collapse. In fact, their natural state is collapse. They only exist briefly when they're being held together by some outside force, but that's not even the worst of it. Even if you could keep a wormhole stable, at least for a moment, once you've got one, you've broken the universe. You see, a wormhole connects to different regions of spacetime. And the thing is that in principle, you can connect any two regions of spacetime to each other regardless of how far apart they are. This means that just having one wormhole around anywhere can destroy causal relations throughout the entire universe. What do I mean by that? Well, causally related events are those where one event could, in principle, have caused the other. Like if you drop a bowling ball on your foot, you can be pretty sure that your foot will break before the bowling ball reaches orbit. But if you dropped that bowling ball on your foot, it could, in principle, cause a gravitational collapse that forms a black hole. And if it did that, it could create a wormhole. And if that happened, well, anything could happen. And I mean anything, like take the example of two friends. Let's call them Benny and Jerry. Benny decides that he wants to go back in time and kill Jerry's father so that Jerry was never born and therefore he would never become Benny's friend. Okay, weird plan, but maybe it'll work. So Benny travels back in time and kills Jerry's dad. But now Jerry, who is going to become Benny's best friend, instead never exists. So how can Benny ever have gone back in time to kill Jerry's dad? Well, he couldn't have because Jerry never existed. And yet Jerry did exist because he went back in time and killed Jerry's dad. This is called a logical contradiction, or more poetically, a grandfather paradox. Now, most physicists would tell you that such paradoxes are impossible because they re-caught on the horns of a logical dilemma. But let's grant that time travel is possible and that killing Jerry's father does, in fact, kill Jerry's father and create a wormhole. Now, in principle, Benny could use that wormhole to get back to his own time and prevent Jerry's father from ever meeting his wife, thereby preventing Jerry from being born, thereby preventing Benny from ever becoming friends with Jerry, and we're off to the races. If we allow even one wormhole into our universe, it's game over for the entire concept of cause and effect. So physicists have proposed that nature prevents wormholes from forming in the first place. That's right, the laws of physics are rigged to stop us from traveling through time. But wait, if that's true, doesn't that mean that it's impossible to travel through time? Well, no, because the laws of physics are also rigged to stop you from breaking the speed of light. And yet we know that it's possible to get close to the speed of light, just not all the way there. Similarly, the laws of physics might be rigged against getting into causal loops, but that doesn't mean it's impossible to come close. Nature has a way of allowing things to happen just up to the point where they would break the laws of physics. and at the very last second, pulling back just enough so that the laws of physics remain intact. We already know that the laws of nature appear to be rigged in this way because quantum mechanics puts an upper limit on how much energy we can put into creating a particle. And if we had particles with arbitrarily high energies, we would rip the universe apart. And yet the universe isn't ripped apart, so the laws of nature must be protecting us from that. Why? Because if we didn't have a law of nature that prevented particles from having arbitrarily high energies, we could take a particle with high enough energy to destroy the universe and run, and then we wouldn't be here to observe the universe being destroyed. And that would be, well, it would be silly. And so physicists think that something similar happens with wormholes. The reason we don't see them is that the laws of physics prevent them from forming. But if they did form, the laws of physics would step in at the last moment to stop them from undoing the Big Bang. Maybe it's a good thing that we haven't found a wormhole yet. The resulting Big Bang heat death of the universe would suck. What would you do if you found a wormhole? Jump through it, punch it in the face, post a picture on social media, tell me about it in the comments below. And while you're down there, you should probably hit the subscribe button. It's free. You can always change your mind later. And until you do, you'll get to watch this next video. I am picking a science news story that I missed last week because I was too busy making videos about giant space rocks and alien hellscapes. It's the news that astronomers have discovered a planet orbiting a star in the habitable zone. That's a region around a star where a planet could have liquid water on its surface. This particular planet is 8 times the mass of the Earth, which means that it's probably a big old rocky planet rather than a gas giant. And it orbits a star that's quite a bit smaller and cooler than the Sun, which means that the star's habitable zone is relatively close to the Sun. So the planet probably gets plenty of heat from its star. All of this sounds promising, but unfortunately, the planet is also extremely bright, which suggests that it has a thick atmosphere that traps heat. So my guess is that the planet is a big ball of hot, dense gas with a very unpleasant surface.